Welcome back. Today we're going to be talking about the best educational tool on the market, the BrainPad. After about 2 years of hard work with teachers, students, schools, we believe we have the best educational tool. It's the BrainPad. The BrainPad can be used as a electronics programming tool, and it can also be used in any STEM program. Meaning you can use it in physics class, you can use it in math, you can use it in science, you can use it in so many ways. If you are using it to learn programming, it's a great tool with Visual Studio, IntelliSense. It makes everything super easy to learn programming, but you're also at the same time learning programming the right way. You're not using like a weird language that somebody invented. It's a language that is used by professionals. Today we have Visual Basic and C# as options. Now, if you're not using BrainPad to learn programming and electronics, you can use BrainPad with a pre-made applications, and those applications can be used to measure acceleration, for example, in a physics class, and those can be shown on the screen and put on a file that you can plot on a PC, for example. Now, with these BrainPads I have right here, we have quickly put a few demos on here just to demonstrate the possibilities with the BrainPad. So I'm going to go through them and show you the different things that we did with the BrainPad with like very, very few lines of code. And these are just examples to give you a quick idea of what things you can do with the BrainPad. This first demo is a little game. This is about 100 lines of code. The idea here was, how much can you do with very, very few lines of code? We're talking about a full game where we shows score and lives and keeps track of your score. So I have a falling ball, yin-yang symbol that's falling down, and then I have used the stick at the bottom to catch it. It's kind of like Pong. So if I'm not playing it right, I'll end up lose. Now I have one life. And it shows you lose, gives you the score. Everything here you see is about 100 lines of code. So you can write a full game quite easily. You need a little bit of experience. This would not be like the first entry level for kids, but it's definitely a quick way to learn things. Now this is a little bit more advanced example. Also about 100 lines of code, maybe 120. So I have like something similar to Space Invaders in this demo. The next demo right here. This is perfect for physics, for example. We here have different circles on the screen that are bouncing around, and the size of circles actually has effects like in real life. If a larger object, that's the weight, it's a larger circle hitting a small circle causes the small circle to go a lot faster. And you can see that over here. The smaller circle is bouncing around really quick, where the larger circle is going really slow. The next one. A 3D cube. We're using trigonometry here, and we're converting from 3D space to 2D space on the screen. A few lines of code, like 10, 20 lines of code. This can also be used where you can, for example, modify this and take the acceleration to like tilt the cube on the screen, or the buttons, temperature. Next example. Over here, I'm just using the acceleration to move the happy face on the screen. And this is also demonstrate how you can rotate. If you have an image and you want to rotate it like 90 degrees, 180 degrees, that's built into the BrainPad driver. This might end up being the demo that ships on the BrainPad. So through this, you can go through everything on the BrainPad and try it. So if I go to the buzzer, increase the frequency. So this is 170 Hertz, for example. Let me show you something else. So the accelerometer, you can graph or show a number. Let's do a graph. So now if I tilt the BrainPad, there's a graph on the screen that shows the acceleration. So how much I have tilted the BrainPad. And this is measuring acceleration, of course, measuring gravity. Now, the BrainPad on its own is terrific. You can do a lot with it. But then what if you want to take this one step further? This is where the BrainPad has an expansion connector, and this connector you can use to add, let me show you on the side how it looks. So you can use this connector to add all kind of modules. Now those are modules that are standardized by a company called Microelectronica, and they make these click modules that have similar pinout. They're similar to shields on an Arduino if you're familiar with that, but they're a lot smaller. So the pinout here is compatible, meaning you can grab any of those click modules, plug them in, and you're ready to use them. We want to provide a lot of these as part of the package that comes with the BrainPad, like drivers, the curriculum, the lesson plan. Everything will be provided to you, so you don't really need to understand everything when you're using, for example, this is an FM click module. You don't need to understand the chip and dig into the datasheet. That would be too much for an educator, for example. But we're providing you the driver for it. So at the end, through IntelliSense, this would be very simple. You just FM radio, dot, and then you get a list of options like volume, station, and whatever options that are available by that specific module. So in this here, I have in this example, I just playing one of the radio stations, and it's playing right here and here. Now I'm also graphing on the screen, doing some trigonometry and drawing like some polar equations on the screen. Now this is two different examples. You can use that to like in a math class, for example, and you can also take on the FM driver and build like a homemade alarm clock that plays radio in the morning. Or any other example you can think of using an FM radio. And we're going to do like other tech talks where we'll maybe take this FM chip, and every episode we talk about building up a project. So at the end you have like this super smart alarm clock. In this example, we want to talk about, let's say in this lesson, you're teaching about transferring data wirelessly. And in this case, the technology used is infrared. So there is infrared transmitter receiver on each one of these BrainPads, and they're transferring data to each other. So the two BrainPads right now that I have plugged in, every time I press a button on one BrainPad, it's going to transfer a number. It's going to transmit a number through infrared to the other BrainPad. And same if I press the other button on the other BrainPad, it will send its own number back to the other BrainPad. So for comparison, now we have 29 showing on both screens. I press the button, and this BrainPad will be counting and incrementing these numbers to the other BrainPad. The other BrainPad is receiving them. Going back to this BrainPad right here, I can press the button, and this will be sending its number back on the other BrainPad. A quick demo to show wireless technologies. Now this can be Bluetooth, can be Wi-Fi, but with infrared there is no setup, just like your TV remote. You don't need to configure anything. It's just data being transmitted from one side to the other. You don't need to understand the details, of course, like everything else, we're providing drivers. Now, you have used the BrainPad on its own, you have used the click modules. There is over 200 of these click different modules that you can use on the BrainPad. And let's say, but you want to take this one step further and you want to do your own thing. So in this case, let's say you want to do robotics. And in this example over here, I have a servo motor. And the servo motor, we have two servo connections on the BrainPad. And this is showing the position of the servo motor. If I press the buttons, it's going one side versus another. This you can, for example, make a large paragraph where this would be like the pointer pointing to let's say the temperature. It could be something large that the students would build, and it would make understanding the concept nicer because they're building something behind it. Another example here, I have a robot, and in this robot, when I press the left button, it will start the cycle, which is it goes forward for 2 seconds and then backward for 2 seconds, and then it spins for 2 seconds. Let me stop it. Now, this is something I found on Amazon, so it's really easy to get the chassis and build it up and add the servos on the back. These are continuous servos, meaning they don't go to a direction like the other servo we just shown. These servos just go complete circle. And the driver that comes with the BrainPad already controlled either or. You can choose which one you want to use. And then I found this really thin battery at Micro Center. It's only $6. It's beautiful battery, really thin, and goes perfectly between the chassis and the BrainPad. So it's concealed down there, and I can use it to power up the BrainPad. Now, you want to be even more advanced. You want to learn about electronics and dig right into the wires and wire things yourself. This will be a perfect example. I added a ultrasonic distance sensor on here, and then with this sensor, I can add like wires from the breadboard they added on the chassis, connect them to these connections right here, the expansion. Those are normally used to add in the click as an intermediate step, but if you want to build your own, this is where you can do that. So you can add the wires over here, and then I'm using the BrainPad to measure distance, for example. I hope you are as excited as we are about the BrainPads. If you don't have a BrainPad yet, talk to us. We have one for you. See you next week.